Now let's go graphing our next four trig functions. That's our tan function, our cotan function, our secant function, and our cosecant function. First, we'll be looking at the graph of the tangent function. We know that the tangent function is an odd function because the tan of negative x is equal to the negative tan of x. This tells us that it's symmetrical around the origin. We also know that tan of x is equal to sine of x over cosine of x. Therefore, when cosine of x is equal to 0, the tan of x is undefined. When the tan of x is undefined, what we have is a vertical asymptote. We know that cosine of x is equal to 0 at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and so on and so forth. If we choose the period from negative pi over 2 to pi over 2, and we choose negative pi over 4, 0, pi over 4 for our x values, we already know that when it's negative pi over 2, y will be undefined. When it's negative pi over 4, we have negative 1, 0, 0, pi over 4 will give us 1, and pi over 2 will make this undefined. If we plot these points, negative pi over 2 is undefined, negative pi over 4 would be equal to negative 1, when it's 0, it's 0, when it's pi over 4, it's going to be equal to 1, and we know our graph moves towards our vertical asymptotes, so our tan graph will then look like this. So, from here to here, negative pi over 2 is a complete period of our tan graph, so our period it would be pi. The range for a tangent function then would be from negative infinity to positive infinity. We know we have a vertical asymptote at pi over 2 plus n pi, where n is any integer. And this would be symmetrical around here, so this would also be true here for another cycle or another period. So here we have the graph of our basic tan function. The general equation of the tangent function can be written in the form of y is equal to a times tan of bx minus c. To find our vertical asymptotes for our tan function, we set bx minus c is equal to negative pi over 2, which is our left vertical asymptote, and bx minus c is equal to pi over 2, which is our right vertical asymptote. Here we'll be looking at this example, y is equal to the tan of 4x. So to find our vertical asymptote, we set bx minus c. Here our c is 0, so we set 4x is equal to negative pi over 2. Solving for x, we have x is equal to negative pi over 8. We also set bx minus c is equal to pi over 2, so we set 4x equal to pi over 2. Solving for x, we get pi over 8. So we have two vertical asymptotes, one at negative pi over 8 and one at pi over 8. So here we have our two vertical asymptotes, negative pi over 8 and pi over 8. So we know our tangent function will be in between these two vertical asymptotes. We know at 0, our tangent for 4x, 4 times 0 is 0, the tan of 0 is 0. When x is equal to pi over 4, then this becomes 1, and this becomes negative 1, so our tangent function will look like this. If we draw in our other vertical asymptotes, we can sketch our corresponding points and draw several periods of this tan function here for x. Here we're graphing the function y is equal to negative 2 times tan of 3x. Since it's a tan function, we can find our two vertical asymptotes by setting 3x is equal to negative pi over 2 and 3x equal to pi over 2. Setting 3x equal to negative pi over 2, we have x is equal to negative pi over 6. And setting 3x is equal to pi over 2, we have x is equal to pi over 6. So here we have two vertical asymptotes, one through negative pi over 6 and one through pi over 6. So our period here would be pi over 3. If we add pi over 3 to pi over 6, we get our next vertical asymptotes. And if we go this direction, we get our next vertical asymptote. Now if we choose some values in between negative pi over 6 and pi over 6 to get our direction of our graph, when we plug in 0 for x, we get 3 times 0 is 0, the tan of 0 is 0, so negative 2 times 0 is 0. When we plug in negative pi over 12, this comes out to be negative 2. So right in between here would be negative pi over 12, which is halfway between the 0 and the pi over 6. We get a value of negative 2. When we plug in pi over 12, this becomes 3 times pi over 12, which is pi over 4. So it becomes negative 1 and 1 times negative 2 is negative 2, so this becomes negative 2. So our sketch of the first period for this graph would look like this. Similarly, the graph in the next other two periods on the right and the left will be the same. So here we have this, a 2 and negative 2. 2 and negative 2. So this would be the graph of our equation y is equal to negative 2 times tan of 3x, showing 3 periods. Here we're looking at the graph of the cotan function. The period for the cotan function is also pi. We know cotan is equal to cosine over sine. Therefore, when sine is equal to 0, we know that a cotan is undefined. And we know sine is equal to 0 when x is equal to 0, or pi, or 2 pi, or n pi, where n is any integer. So, to find our vertical asymptotes for a cosine cotan function, we can set the bx minus c equal to 0 and bx minus c is equal to pi. Here we're looking at this example. Y is equal to 3 cotan of 2x. 2x is our bx minus c, where our c in this would be equal to 0. So we're going to set our bx minus c equal to 0 and our bx minus c equal to pi. Solving for x, we have x equal to 0 and x is equal to pi over 2. These are our two vertical asymptotes. So here we have 0 and pi over 2. So one period of our cotan function for this equation is from 0 to pi over 2. If we add pi over 2 to this, we have another period, which is pi. If we went in this direction, another period, and another period. So in between here, we have pi over 4. At pi over 4, we know the cotan will be equal to 0. When it's pi over 8, looking at pi over 8, this becomes 2 pi over 8, which is pi over 4. The cotan of pi over 4 is 1, so 3 times 1 is 3. So this will give us, let's put in some numbers here, 3. So when it's pi over 8, we have 3. Similarly, when it's pi, or division here, we'll have 1, 2, 3, negative 3. So our cotan function, as we can see, is the inverse of our tan function going in this direction. Similarly, our next period will look identical to that. So here we have the graph of y is equal to 3 cotan 2x.